So okay, yeah. Um, Good day, guys. So today we'll be discussing air, the composition of air, and basically environmental pollution. So this is the fifth chemistry tutorial, if I'm not mistaken. So let's shoot. Okay, so the mixture of gases that makes up Earth's atmosphere is known as air. So don't forget, one thing I always want the students to understand is we are not in the earth, we are just on the earth. Then the mixture of gases, mixture in quotes, mixture of gases around that head, around that sphere is what we know as the air. Okay, nitrogen makes up 78% of this gas, which is mixed with 21% oxygen, water vapor, which is variable, argon, which is part of the noble gases we have there, which is about 0.9%, carbon dioxide, actually about 0.03%, and trace gases. There is no apparent scent or color in pure air. Dust, pollen, spores are common contaminations in air. Additional contaminants are referred to as air pollutants. Shey get. So, because there is no air in space, so the so-called air on other planets, such as Mars, would have a different composition. That's just the idea. In here on Earth, we have 78 nitrogen, 21 oxygen. In other place, you might have oxygen more abundant than other. Shey get. In fact, in some other planets, it is possible that it is because there is lower oxygen that life does not really exist there. Do you get my point? Okay, moving to the next. So the component of air. So we have what nitrogen, oxygen, noble gases, carbon dioxide, impurities. So nitrogen making up 78, oxygen which is 21 or 20.9%. Then the noble gas is basically they are just about 1%, where argon is the most abundant. Let's note that argon is the most abundant noble gas in the atmosphere, which is about 0.9%. The carbon dioxide, which is about 0.03%. And that's it. That's just the basic component of air, and these components basically they are also variable depending on location. Although the constant guys there, they are what nitrogen, oxygen, carbon dioxide. Okay, the nitrogen, which is 78% now. So let's discuss that. So this is the component of air that is stable and serve as a diluent because it dilutes the what the action of oxygen. It dilutes the what the action of oxygen. That's why they call it a diluent. And those two actions it dilutes is what combustion and corrosion. Imagine oxygen is about 100% in air, or let me even say about 70%. That means everything will start burning on just little spark. Metals will be corroding faster. You will not even see a new metal that will be shiny. Everything will just be what will be corroding. Do you get my point? So that's just what I explained there. So nitrogen atoms in the nitrogen atoms in nitrogen gas, which is in air, they are binded together by three or strong covalent bonds, which are very very hard to break. But your this thing, your lightning can break it. Thunder strike breaks it. Then helps in what nitrogen fixation into the soil for plant usage. That's that. For the nitrogen is a very very important component or nutrient for plants. Okay, coming to oxygen. Oxygen is a very important component of it that helps in what combustion and what corrosion. So oxygen also very important in life as it is used in what respiration, which is for oxidation of food glucose. That's basically respiration for oxidation. Then decomposition of organic materials. Oxygen is also useful there. The noble gases, the most abundant noble gas in air is what is argon. I said that already. The noble gases are used to form inert atmosphere, typically for arc welding to protect specimens and to deter chemical reactions. Because noble gases are inert gases, their presence actually helps in what in providing an inert environment in arc welding that they need a lot of reactions to occur. So if you have an inert environment, everything will not just be reacting. That's just the idea. Because during arc welding, we are reaching a very, very high temperature. And then in order to have an inert environment to stop the gases from reacting, we need what? An inert gas, which is argon in this case. So noble gas makes up about 1% of the Earth's core, which their major component is argon. I said that already. Then the smaller concentrations are included in igneous rock, but the atmosphere is the principal commercial source of neon, argon, krypton, and xenon, which are obtained as byproducts of the liquefaction and separation of air. Liquefaction of air in the sense of turning air into liquid, then separation of air, just like we explained in fractional distillation, that you can use your fractional distillation to separate the component of liquefied air. So that's also what they are saying here. So carbon dioxide now, which is 0.03%. CO2 is very, very important component of air. It helps in little amount to the control of combustion because carbon dioxide does not support combustion, it extinguishes fire. Okay. CO2 is also essential for that as a major raw material in photosynthesis. During photosynthesis, we need two things, water and CO2. And the presence of what? Sunlight that will be trapped by what? Chlorophyll. So CO2 is also very, very important in the manufacture of what? Of food, which is glucose through the process of photosynthesis. Carbon dioxide is used as refrigerant in fire extinguishers, for inflating life rafts and life jackets, blasting coal, foaming rubber and plastics, and in carbonated beverages. When you open your carbonated drinks, after opening it, what do you see? What do you hear? You hear the gas coming out is just what? Carbon dioxide. That's the gas added to beverage. In fact, that's why they call them carbonated drinks, because when you add CO2 to those drinks, it reacts with water to form what? Carbonic acid. Moving on, we are going to discuss way more when we are discussing salt analysis and taking these gases in depth. But this is just relating to what? Environmental pollution and the component of air. So the impurities in what? In air now, they are actually very, very variable in percentage, because my room here, I can see there's no impurity. Then somewhere else where they are doing a lot of industrial stuffs, so you expect to have more high high impurity content there. Do you get my point? So that's that. So we can have carbon monoxide, lead, nitrogen oxide, ozone, particulate matter, sulfur dioxide, carbon dioxide. Even CO2 can also be an impurity. Well, basically in air. In air, I was about moving into air pollutants. In air, these are the most common what impurities we have. So these impurities vary in composition as they come from different sources and human actions. So the environmental pollution now. So environment is the surrounding of conditions in which a person, animal, or plant lives or operates. Environmental pollution is the occurrence of substance in amount exceeding their normal concentrations in any part of the environment. When you have them exceeding their normal concentration, if oxygen itself is getting too much, we can start seeing is what it is polluting the air. That's just the idea. So this can be in any form. It can be air, water, or soil pollution. Okay. Pollutants include the impurities of for air pollution now. Pollutants include the impurities of air and even carbon dioxide. Impurities of air, just like I mentioned, um, yeah, yeah. All these impurities, they are also impurities in air. Shey you get? So as I'm not saying, in air pollution, it increase the pollutants of this air pollution increase impurities in air and even carbon dioxide, which even though a normal concentration of air is produced additionally as a pollutant through some processes. So when you have CO2 adding more like it is going more than usual, you call it a pollutant, because that's a very, very adverse effect in global warming and all. So then, okay, so let's talk about this air pollutants one after the other. The dust. So dust basically, they also call it the particulate matter. Okay, so dust containing lead and some other heavy metals usually arises from agricultural practices, vehicular emissions, industrial operations, and even natural deposition like harmattan dust and volcanic eruption. Dust is made up of what fine particles of solid matters, of course. So on Earth, it generally consists of particles in the atmosphere that comes from various sources such as soil lifted by wind, volcanic eruptions, and pollution. Okay, all these things are still just normal dust we know. Okay, so however, dust particles themselves are well known for their potential to cause respiratory and cardiovascular health problems. They can also irritate eyes, throat, and skin. You know what that is? If dust enters the eye, you start itching it and all. That's what irritation of the eye. So human health affects if human health effect of dust relates mainly to the size of dust particles. The bigger the dust particle is, the more adverse the effect is going to have on you. So coming to the carbon, nitrogen, and sulfur oxides, they usually arise from fossil fuel combustion, including bush burning. Fossil fuel in the sense of when you are talking about biological fuels, basically, something like coal, yeah, coal, the combustion of coal and all. So they gave us the oxides of carbon, hydrogen, and sulfur. Okay, they also arise from various industrial processes. CO2 is emitted during cement production. Sulfur and nitrogen oxides from fertilizer manufacture. So sulfur and nitrogen oxide cause respiratory problems and acid rain. That makes sense in the sense that when you have sulfur oxide in the atmosphere, it can form H2SO3, or even if it is SO3, it can form H2SO4, and NO2 can form what? HNO2 and HNO3, leading to acid rain. So when they are in the atmosphere and rain falls, so the water coming and then these gases mix together, react together to form an acid, which leads to what? Acid rain. And you know the effect of acid rain. In companies creating sculptures, it starts um, kind of breaking the sculptures down because the reaction will start occurring between the sculpture and the acid. So, carbon monoxide causes obstruction of oxygen transport in the blood, thus affecting cardiovascular, nervous, and pulmonary system. The effect of CO in respiration is that CO and oxygen kind of look alike to the hemoglobin that is transporting oxygen. So anytime hemoglobin takes oxygen, it can also drop it. But when it takes CO, it can never drop it. It's irreversible. So in that case, you can use up your hemoglobin with what? CO. Then when you use it up, you get kind of short of what? Oxygen. And if you are short of oxygen, your brain needs oxygen for proper function. You start having what? Mental retardation. So carbon dioxide causes global warming through a phenomenon called the greenhouse effect, leading to rising sea levels. So it's just about in very very cold countries with ice. So high CO2 in atmosphere can lead to the melting of this ice through the greenhouse effect. You can read on greenhouse effect. I don't want to mention it now. You will definitely not check. So just check it out. So is it sorry for that. So the heights will start melting, leading to what? Flood. She gets. So and if they ask you what's the major consequence of global warming, it's just flooding. Do you get my point? So hydrocarbons and heavy metals. So these are emitted from various industrial and domestic activities. Lead in form of tetraethyl lead. Basically, that's what they use in anti-blocking agent, anti-knocking agent for petrols. That's what the gasoline. That's like kerosene anti-knocking agent. Because when you have a very very a petrol or a gasoline with low octane rating, you can add that lead tetraethyl or tetraethyl lead to reduce the knocking ability of the petrol of the fuel. So gaseous hydrocarbons are emitted into the atmosphere from evaporation of organic solvents, liquid fuels, and other organic compounds, in particular chlorofluorocarbons, and emitted from air conditioners, note that refrigerators and aerosol sprays. Lead has a great negative effect on nervous coordination, which leads to what? Mental retardation, just like your CO. So CFC breaches ozone layer, which the work of ozone layer is just to help in what? Preventing direct radiation from the sun down to the earth. Ozone layer is just like a layer called kind of protecting the hair from the radiations, infrared rays coming from the sun directly. But when your chlorofluorocarbons bleaches the ozone layer, the radiation starts eating the head, then cancer, the rate at which people get cancer increases. So some hydrocarbons, the volatile organic hydrocarbons VOCs, are carcinogenic, they are cancer causing. And in combination with nitrogen oxides causes what? Photochemical smog. What's smog? Smog basically is just the mixture of smoke and fog. So ozone can also be a pollutant basically. Don't forget it's a layer protecting the earth, but if it is closer to the earth surface where people are living, it causes a lot of issues. So the major component of smog is what? Ozone. So and then the major component of ozone is smog rather. Oh, what am I saying? The major component of smog is ozone. Yeah. So smog is air pollution that reduces what? Visibility, just like fog. When you start having fog like kurukuru in Yoruba, so it reduces visibility. The term smog was first used in early 1900 to describe a mix of smoke and fog. In English language, that's what we call blending. When you blend two words together, They're just like you have breakfast, brunch, and lunch. So when you mix breakfast and lunch together, you have brunch. That's the one you eat in between breakfast and lunch. So that's blending of words to form a new word. So ozone is a secondary pollutant because it is formed from other pollutants. Ozone normally is not just a pollutant on its own that is coming from a source. Many other some primary pollutants are coming together, reacting together to form ozone. So that makes ozone a what? A secondary pollutant. So ozone in low altitude causes serious respiratory problems such as breathing and asthma in addition to inducing infections. That's that about ozone. So water pollution. So water pollution basically is just kind of a pollution we are having as a result of what? Abnormal or high content of some substance in water more than what they are actually supposed to be. So water pollution is the contamination of water sources by substances which make the water unusable for drinking, cooking, cleaning, swimming, and other activities. That's the idea. Anything that kind of render the water useless or you cannot use it to, you cannot drink it, or then you can see the water is polluted. All forms of pollution may eventually make their way into water, yes. Because if you have acid rain, it's still going into water. If you have anything in the atmosphere or land, even oil in land can leak into water bodies. So when pollutants of various types find their way into water from various sources, they change the physical, chemical, and biological properties of water, rendering it what? Unusable for drinking. Okay, then to the last one, soil pollution. Soil pollution refers to the contamination of soil with a normal low concentration of toxic substances. Normally, the soil is not something that is healthy for human being to just take in like that. It is still toxic. But when you're not having higher concentration of this toxicity, then you cannot say your soil is polluted. So it's a serious environmental concern since it harbors many health hazards. For example, exposure to soil containing high concentration of benzene increases the risk of contracting leukemia. Note that benzene and leukemia, you can link that. Then the root cause of soil pollution is often one of the following: agriculture, excessive industrial activities, poor management or efficient disposal of waste. And that's that for this